Welcome to Summarize Science. Have you ever wondered why we don't have robot butlers yet, even though AI seems so incredibly smart? A big part of the problem is that the most powerful AI models are huge and slow, making them impractical for real-world robots. When scientists try to shrink them to make them more efficient, the robots often lose crucial skills, especially understanding where things are in 3D space. But what if the solution wasn't to remove information, but to reuse something that was being thrown away? This paper, RetoVLA, introduces a brilliant new approach based on something called register tokens. Think of these tokens as a temporary scratch pad that an AI vision system uses to make sense of an image. Until now, after the AI used the scratch pad, the information on it was simply discarded as digital trash. The key innovation here, shown in this diagram, is a new pathway that takes this supposedly useless information and injects it directly into the robot's decision-making center. The researchers hypothesized that this discarded data wasn't noise at all. Instead, it's a valuable, compressed summary of the entire scene's layout and the spatial relationships between objects. For a robot trying to navigate the real world, that kind of information is pure gold. And the results are nothing short of spectacular. This chart shows their new model, RetoVLA in green, compared to a standard lightweight model in yellow. On complex tasks, the performance jump is massive, showing an average improvement of over 17%. Looking at the numbers from their real-world robot tests is even more impressive. For a task like build domino line, the success rate jumped from a dismal 12% to 40%. And for close drawer, it went from 60% all the way to 96%. This isn't a small tweak, it's a fundamental improvement in the robot's spatial intelligence. Here's a perfect visual example of what that means. The robot is told to pick up the black bowl in the top drawer. The standard model gets confused and grabs a similar object nearby. But RetoVLA, using its extra spatial context from the reused tokens, correctly identifies the top drawer and completes the task. So, let's recap the breakthrough here. Scientists took information that every other model was throwing away, realized it contained a secret map of the robot's surroundings, and fed it back into the robot's brain. This simple act of digital recycling dramatically improved the robot's ability to understand and interact with complex 3D spaces without making the model bigger or slower. What does this mean for the future? It's a huge step towards creating robotic intelligence that is both efficient and highly capable. This could lead to more affordable and smarter robots that can perform complex tasks in factories, warehouses, and maybe one day, even our homes. This is a fantastic example of clever engineering, finding immense value where no one else was looking. Thanks for watching Summarize Science.